Uffer, also known as common electrode equivalents, and supplemental ground rod are crucial components of a comprehensive lightning protection system. Their primary function is to provide a low-resistance pathway for lightning energy to safely dissipate into the earth. When lightning strikes a structure, it invariably seeks the path of least resistance to ground. A properly installed lightning protection system, incorporating both the Uffer and a supplemental ground rod, offers this dedicated pathway, guiding the immense lightning current away from sensitive electrical systems and the building structure itself. In the scenario described, the limited damage to the electrical system, specifically only one dimmer switch on the same ungrounded circuit as the computer, despite the substantial burn damage to the roof ridge and wooden structural members, strongly suggests that the Uffer and supplemental ground rod performed their intended function effectively. The lightning current likely followed the path of least resistance provided by the lightning protection system, safely discharging into the earth and thereby minimizing the potential for widespread damage to the interior of the house. However, it is crucial to acknowledge that the effectiveness of any lightning protection system is contingent upon several factors. Firstly, proper installation is paramount. The system must be installed in accordance with established standards and best practices, ensuring that all components are correctly connected and grounded. Secondly, the specific characteristics of the lightning strike itself play a significant role. The magnitude of the current, the duration of the strike, and the point of impact all influence the extent of damage that can occur. Thirdly, the overall grounding system of the house is very important. Therefore, based on the available information, it is reasonable to infer that the Uffer and supplemental ground rod played a vital role in effectively dissipating lightning energy in the described scenario. Their presence likely prevented far more extensive damage to the electrical system and the interior of the house. Understanding the role of the Uffer ground involves looking at its connection to the building's grounding system. The Uffer ground, typically encased in concrete, provides a large surface area for electrical dissipation. This connection is critical for managing fault currents and providing a safe path for electricity. A ground rod serves a similar purpose, offering an additional path to earth. The combination of these grounding techniques enhances the overall safety and protection of a structure. Electrical grounding systems are designed to protect buildings and people from electrical faults. Proper grounding ensures that in the event of a fault, such as a short circuit, the electrical current will flow safely to the ground, tripping a circuit breaker or fuse and preventing electrical shock or fire. The effectiveness of a grounding system depends on several factors, including the type of soil, the depth and placement of the ground rods, and the quality of the connections. Regular inspection and maintenance of grounding systems are essential to ensure their continued effectiveness. This includes checking for corrosion, loose connections, and damage to ground rods or wiring. In addition to grounding, surge protection devices play a critical role in protecting electrical equipment from voltage spikes. These devices, often installed at the service entrance and at individual outlets, divert excess voltage to the ground, preventing damage to sensitive electronics. Surge protection is particularly important in areas prone to lightning strikes or power surges. Understanding electrical codes and regulations is crucial for ensuring the safety and compliance of electrical installations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical wiring, grounding, and protection. Compliance with these codes helps to minimize the risk of electrical hazards and ensures the safe operation of electrical systems. When designing an electrical system, it is essential to consider the specific needs and requirements of the building. This includes determining the appropriate size and type of wiring, selecting the right circuit breakers and fuses, and planning the layout of electrical outlets and lighting fixtures. A well-designed electrical system should be both functional and safe, providing reliable power while minimizing the risk of electrical hazards. Proper maintenance of electrical systems is also essential for ensuring their continued safety and reliability. This includes regularly inspecting wiring, replacing worn or damaged components, and testing ground fault circuit interrupters or GFCIs. Addressing electrical issues promptly can prevent more serious problems from developing. In the context of a lightning strike, the grounding system works in conjunction with lightning rods and surge protection devices to provide comprehensive protection. Lightning rods provide a preferred path for lightning to strike, directing the current to the ground through a low-impedance conductor. Surge protection devices then help to mitigate any remaining voltage spikes, protecting sensitive electronic equipment. The effectiveness of a lightning protection system depends on the proper installation and maintenance of all its components. This includes ensuring that lightning rods are properly grounded, that surge protection devices are functioning correctly, and that the grounding system is in good condition. Regular inspections and testing are essential to identify and address any potential issues. In addition to protecting against lightning strikes, grounding systems also play a crucial role in preventing electrical shock hazards. By providing a low-resistance path to the ground, grounding systems help to ensure that fault currents are safely dissipated, preventing dangerous voltage levels from developing on exposed metal surfaces. This is particularly important in areas where people may come into contact with electrical equipment, such as kitchens, bathrooms, and outdoor areas. Ground fault circuit interrupters, or GFCIs, are another important safety device that helps to protect against electrical shock hazards. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. This can prevent a potentially fatal electrical shock. GFCIs are typically required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Electrical safety is a shared responsibility, and it is important for everyone to be aware of the potential hazards associated with electricity. This includes avoiding contact with exposed wires, using caution when working with electrical equipment, and following all safety guidelines and regulations. By taking these precautions, we can help to prevent electrical accidents and injuries. When it comes to protecting a home or building from lightning strikes, there are several key components to consider, not only the Uffer ground. One of these components is the lightning rod system, which is designed to provide a preferred path for lightning to strike, directing the current to the ground through a low-impedance conductor. The effectiveness of a lightning rod system depends on several factors, including the height and placement of the rods, the size and conductivity of the conductors, and the quality of the grounding system. A well-designed and properly installed lightning rod system can significantly reduce the risk of damage from a direct lightning strike. Another important component of a lightning protection system is the surge protection device, or SPD. SPD are designed to protect electrical equipment from voltage spikes caused by lightning strikes or other electrical disturbances. These devices divert excess voltage to the ground, preventing damage to sensitive electronic equipment. SPD are typically installed at the service entrance and at individual outlets, providing comprehensive protection for the entire electrical system. The grounding system is another critical aspect of lightning protection. A properly designed and installed grounding system provides a low-resistance path for lightning current to flow to the earth, minimizing the risk of damage to the building and its contents. The grounding system should be connected to all metal components of the building, including the electrical system, plumbing system, and structural steel. Regular inspections and maintenance are essential to ensure that the grounding system is in good condition. In addition to these physical components, there are also several important electrical safety practices that can help to protect against lightning strikes. One of these is to avoid using electrical appliances or electronic equipment during a thunderstorm. If possible, unplug these devices to prevent damage from voltage spikes. Another important safety practice is to stay away from windows and doors during a thunderstorm, as these areas can be more vulnerable to lightning strikes. Electrical codes and standards play a crucial role in ensuring the safety of electrical systems. These codes and standards provide comprehensive guidelines for electrical wiring, grounding, and protection, helping to minimize the risk of electrical hazards. Compliance with these codes and standards is essential for all electrical installations, whether they are in residential, commercial, or industrial buildings. Electrical safety is a shared responsibility, and it is important for everyone to be aware of the potential hazards associated with electricity. By following safe electrical practices and ensuring that electrical systems are properly installed and maintained, we can help to prevent electrical accidents and injuries. When dealing with electrical systems and lightning protection, it is important to understand the terminology and concepts involved. Firstly, grounding refers to the process of connecting electrical equipment or systems to the earth, providing a low-resistance path for fault currents to flow. Secondly, bonding is the process of connecting different metal components of a building together, creating an electrically continuous path that helps to minimize voltage differences. Thirdly, surge protection refers to the use of devices that protect electrical equipment from voltage spikes caused by lightning strikes or other electrical disturbances. Understanding these terms and concepts is essential for ensuring the safety and reliability of electrical systems. When it comes to electrical safety, there are several common misconceptions that should be addressed. One common misconception is that rubber tires provide protection from lightning strikes. While rubber tires can provide some insulation, they do not offer adequate protection from the high voltage of a lightning strike. Another common misconception is that surge protectors can protect against all types of electrical surges. While surge protectors can help to mitigate voltage spikes, they are not effective against direct lightning strikes or other high-energy surges. It is important to have a comprehensive lightning protection system in place to protect against all types of electrical hazards. Electrical safety should be a top priority for everyone, whether they are homeowners, contractors, or electricians. By following safe electrical practices and ensuring that electrical systems are properly installed and maintained, we can help to prevent electrical accidents and injuries. The Uffer ground, also known as a concrete encased electrode, is a grounding electrode that is encased in concrete. It is commonly used in new construction to provide a low-resistance path to ground for electrical systems. The Uffer ground typically consists of a length of rebar or copper wire that is embedded in the concrete foundation of a building. The concrete provides a large surface area for contact with the earth, which helps to improve the grounding performance. Supplemental ground rods are additional grounding electrodes that are installed to supplement the Uffer ground. These ground rods are typically driven into the earth near the building and are connected to the grounding system. Supplemental ground rods can help to further reduce the resistance to ground and improve the overall grounding performance. The combination of an Uffer ground and supplemental ground rods can provide a very effective grounding system for electrical systems. This is particularly important in areas where the soil is not very conductive or where there is a high risk of lightning strikes. Proper grounding is essential for electrical safety as it helps to protect against electrical shock hazards and damage to electrical equipment. A well-designed and properly installed grounding system can help to ensure that fault currents are safely dissipated, preventing dangerous voltage levels from developing on exposed metal surfaces. Regular inspections and maintenance are essential to ensure that the grounding system is in good condition and functioning properly. Electrical safety is a shared responsibility, and it is important for everyone to be aware of the potential hazards associated with electricity. By following safe electrical practices and ensuring that electrical systems are properly installed and maintained, we can help to prevent electrical accidents and injuries.